chapter 3 is one of the hardest chapters of the year, okay? So I'm not telling you that to scare you, because it is one of the hardest chapters. It is also one of the tests that students tend to do the best on, because I will harp on you through the entire unit and make sure you're getting your stuff done. And a big thing is you need to stay on top of your homework for this unit. So if we have work time, you got to be doing it. Some people at the end of this unit are like, I don't know why you talked about it. It really wasn't that bad. That's because you did your homework and you pretty much did what you needed to, all right? But the thing is, if you kind of slack off, it is the hardest chapter to catch up on, okay? So it is not a scary chapter. It is a different chapter, but it does not have to be that bad, okay? So today we're starting with 3.1. If you missed the test, please go to the MRC and take that relatively soon. I'm not going to lie to you. I'm not going to get the test back to you on Thursday, okay? I'm gone tomorrow for coaching, and yeah, it's just not happening. So you will get them next week. So I'm not going to harp on you to finish the test if you have not taken it yet as much, okay? But please get that done before next week. So starting off, we're just going to kind of review the forms really quickly. So we have standard form, and you tell me what is standard form good at finding, or tell me what is not good at finding. Is it good at finding it or bad at finding it? Bad. I like bad. We're going to cross that off. I actually wouldn't necessarily find your x-intercepts with standard form unless you did a bunch of other work. Okay? Axis of symmetry, vertex, y-intercept, concavity. What are we thinking?
You can find concavity by looking at A.
Yeah, so we can look at A. And so A is greater than 0, or a positive number. It goes up. And if A is less than 0, it goes down. Okay? How about the axis of symmetry? How do you find that? How would I find the axis of symmetry of that? Yeah, it's the formula thing. So axis of symmetry would be this. Okay. Now, we actually can find our vertex with that. So my vertex is actually negative b divided by 2a. And then what we did is we plugged it in, and mathematically, to show we're plugging it in, I just put f of whatever that number is. And so it kind of looks like that. And then our y-intercept, how do we find our y-intercept? It's 0, comma what? What would it be for this problem? 0, comma 0, comma c, or 7, right? So 0, comma c. All right, so what we're going to do is we're going to change forms really quick. So if I look at this, I want to rewrite this from standard form to factored form. All we have to do, folks, is factor it. So you tell me I'm going to have a 2x and an x. What are my factors of 6 that I can use?
1 and 6.
Keep going. Nice. So now, which ones am I going to use to get them to add up to 7?
1 and 6, 2 and 3.
I hear 2 and 3 more commonly. Where should I put the 2? Right there? Beginning or at the end?
You want to add the normal x.
The normal x? All right, so we'll try that. We're going to check it. So remember, anytime there's a number in front that's not just x or 1, I'm going to check. And so this, I check the first and the last, gives me 4x. And that gives me 3x, which indeed is 7x. So it checks out. All right, so folks, that's how you convert something from standard form to factored form. Question? All right. We good if I move to the next one? This kind of just reviews what we did the past couple days. So x-intercepts, I'm going to write this out since we got that funky notation. But when you're given factored form, x-intercepts are really nice. They would simply be r1, 0 and r2, 0. And the reason we call them r is because they're actually called roots. That's another name for it. Now, concavity, same as the previous. So I'm just going to write same. What about the axis of symmetry? You know that one, potentially, with what we got? Yeah?
It's in the middle of R1 and R2.
Yeah, so it's in the middle of it. So to write that, I would put down that x equals R1 plus R2 divided by 2. And so our vertex and our axis of symmetry have the same x-coordinate, so I can write it like this. And then, remember, we're just plugging something in. So I would actually just put f of, that's the nice thing is instead of writing plug in all of this, I can write f of this, and it means the same thing. And it gives me a solution. So that would be my vertex. And then the y-intercept, we plug in x equals 0, or we find f of 0. They mean the same thing. Questions? All right, we're going to change this from factored form into standard form. You've done this for a while, but we're going to all do it the same way. I'm going to put a bar down, and I'm doing this because eventually you're going to have like 4 of those things that you have to put together. Not in this chapter, but later on. And so I'm going to start just by distributing that. And so I get g of x is equal to negative 2x minus 6. Now that's in parentheses because I'm still multiplying it by x minus 5. And now I want you to double distribute and finish that off. And I'll give you a minute as a head start. All right, folks, so we start distributing, and I get g of x equals negative 2x squared, and then I get a positive 10x. Flip-flopping colors here. We get negative 6x plus 30. Am I done? And so we end up with this lovely standard form. Okay, so you've switched from factor to standard and you've done standard to factor. There's one additional form that we haven't tackled yet. What's the last form? Vertex form, that's right. So vertex form, my favorite form, There's a little bit more work to it. And there's a little less work to it too. It's not too bad. So we actually start with our vertex. So our vertex is h comma k. We have our axis of symmetry, which is going to be x equals h. We have our x-intercepts, which we're not going to worry about for right now. I'm actually going to cross that off for a moment. You're going to start finding them actually in this unit. We get better at that. Concavity is the same as it's always been. And our y-intercept, we plug in 0. Now we're going to change that to standard form. And it's a little bit more work than what we just did. So to change this into standard form, what I need you to realize is that square does not make this x squared minus 9. Okay, that's not correct. What it makes it is it makes it 2 times x minus 3 times x minus 3 plus 4. And so this time, I'm actually going to recommend doing the problem slightly different. In the last problem, we multiplied the 2 into the function right away. This time, I'm going to put my bar there and say, let's go x minus 3 times x minus 3 and see what we get. And what I need you to realize is if I go 2 times 3 times 4, or I go 4 times 3 times 2, it's working out. So we can do that, okay? Shout it out for me. X times x gives me. Keep going.
Minus 3x. Minus 3x. Plus 9.
Awesome. Now, the mistake I see people make is they get to here and then they take that 2 and they start running across. Don't do that. If you can simplify, always simplify. I know it takes another line of work. You have an eraser, you can also do that. So I'm going to get 2 times x squared minus 6x plus 9 plus 4. Then we go and we distribute 2. So we got 2x squared minus 12x plus 18 People always forget the plus 4. This thing just gets lost in whatever we're doing, okay? So just make sure you hold on to that thing. That thing is holding on for dear life. Please don't leave me. Please don't forget me. It's like your younger sibling on a road trip. They go to the bathroom or something, you drive away, and you're like, shoot, we forgot them. Yep. Nope, you got to hold on. So that person has to get combined at the very end. So we get h of x equals this lovely solution. So we've done standard to factored, factored to standard. We've done vertex to standard. And now is the joy of we're going to take a standard and we're going to go to vertex. So it's a new process. It is called completing the square. And you notice that we have exactly one mod left of class. And that's intentional because it's the longest method. It's going to take you the most time. You've seen and done stuff that looks like this, right? You've distributed, you've done that before. This is a little bit new, and so I'm actually going to talk about these first. Let's factor this really quickly, okay? What does this factor to? Three and 3. What's this factor to?
Minus 3,
Minus 3 minus 3. What's this factor to?
5 plus 1.
about this one?
4.
Geniuses. Geniuses. All right. Here's the deal. How does 3 compare to 6? Yeah. How does 10 compare to 5?
Multiply. Add 10 to 5. Wait, 5 times 5.
5
equals 10.
5 times.
5 plus 5. You can add 5.
Hold up. 5 times 5 does give me 25. Okay? 3 times 3 does give me 9 for both of these, negative or positive. What's half of 6?
3.
What's half of negative 6?
Negative 3.
What's half of 10?
5.
Do you see how these numbers are kind of relating? There's something that's going on. I'm taking this middle term, and I can divide it by 2, and that gives me the number that goes right there. Right? If I take b and divide it by 2, it gives me that, which is kind of helpful. What happens if I take this 3 and I get 9? I go 3 times 3. So really what I'm doing is I'm squaring it. Okay? Now we are going to use this little thing right here that is just a pattern on this next part of the problem. So here it is. We are going to convert each quadratic function in standard form equations to vertex form. This is how you do it. Your first step. You do this every time. I'm going to do this as I'm going to take g of x and I'm going to move c over. So I'm going to subtract 2 to both sides. So I get g of x minus 2, and I'm going to leave a big box. So I'm going to put plus a box is equal to x squared plus 6x plus a box. This method is called completing the square. We're going to complete the square. We're going to put something in here so that this factors perfectly, and we can then convert it to vertex form. Now, what number goes right here? I want to factor this. So I want it to factor like this, and I want to have the same numbers. So I can write it as x plus 3 squared, x minus 3 squared, x plus 5 squared, so on and so forth. So how you get this right here is by using that. So b is 6. So what's half of 6?
3.
3 squared is?
9.
So I put 9 here, and I put 9 over there. Now, careful when you're thinking about this, because a lot of people get very good at this part, but they forget to put the 9 over there. You got to remember that an equal sign means that it's a scale. If I add 9 bubblers to one side of the scale and I don't to the other, they are no longer equal. I can add anything I want here. As long as they are equal, nothing has changed. Okay? So in this case, I'm adding 9 here. I add 9 there. The reason being is now I can factor this. And this factors, you already told me this, to x plus 3 and x plus 3, which I can write as a square. And I'm going to put this down here. So g of x plus 7. I just combined these two things. I need to get that over. So I'm going to minus 7, and I get g of x is equal to x plus 3 squared minus 7. What's the vertex of this function right here? What's the vertex of this? Negative 3 and 7. Yeah. So if I ask you what's the vertex of this, you can't tell me. You would do some work and you would get an answer. we can change form so that we can see what we want. Now, I would say that, it's probably about the same amount of work to just use the formula and get that. But it is beneficial to be able to change forms, and completing the square is something that can be very nice in terms of solving quadratics later on. So that's why we're showing it to you right now. So, what questions do we have? We're going to start this next one. We're going to do it together. This is here as a guide. What was the first step I did on number 1 that I need to do to number 2? Subtract 13. I need to move C over. So I subtract 13. And so I have h of x minus 13 equals x squared minus 10x. What do I do next? What's missing that has, that this does not? The squares. I need to have the boxes in there. So I'm going to add a box to both of them. Might be important. How do I fill that box? I love it, but no. We use this. What is half of negative 10?
5.
Negative 5. Now, I'm going to talk about that negative 5 in a minute. What's negative 5 squared?
25.
So
Negative 25.
Positive 25, so that goes in the box. Get out of here. So this comes from negative 10 divided by 2 squared. Now, we factor this. And we simplify what is on the left-hand side. What does this factor to? I'm going to write that twice, just so people can see it. But then you can also realize this is x minus 5 squared. Now, what's negative 10 divided by 2? It's always that, okay? Notice, 6 divided by 2, 3, okay? It actually gives you what this thing factors to as you're doing the problem, all right? So we got that. Last step, slide that negative 12 over. What questions do you have? So I combine these to get positive 12. Okay, so whatever's in the box, you have to add to whatever number's there. So that's how I got 12. And then you take that negative 12 over. That's a really good question. Any other questions?
Yeah, so should you do your 25 over the x minus 5 squared itself? So then it would be 13. Should there be
Are you talking right here?
no, down. Yeah. You were like the middle where you each makes them right over to the other side of the equal sign. Yeah, no, down. A little over to the right. That's how you can see where it's from.
Right here?
It shouldn't be there.
A plus 25.
Yeah, should. Or,
No, because we factor that, right?
Oh, okay.
Because this right here factors x minus 5x minus 5. Because negative 5 times negative 5 is 25. And negative 5 plus negative 5 is the 10. Does that make sense? All right. Other questions? Do you hear the call? Are you going to answer the call? Yeah, we're going to answer the call. You do number 3. Work together. Talk to each other. I'll come around and check it. No, I'm just looking at your work. This is your answer. Yeah.
Half of 8, 4 times 4 squared.
Oh, no, it's 4. Yeah, but your
I mean, you said get the right.
That's how you get the numbers. 4 squared, so 16.
I'm glad you got
16
it.
is the box. Nobody had it.
A lot of people have just like been
Also
confused.
for that box equals x plus 4 squared. So plus 16. Yeah. Okay. So then I simplify. So fx.
Folks, I tell you I don't want you to memorize a bunch of things. I don't need you to memorize that. Okay? It really comes down to thinking about what number can I just put in a box to make it so it factors perfectly. If you want to memorize it, go for it. You're going to do a bunch of these problems anyways. You might memorize it anyways. But regardless, please just practice it. Okay? Completing the square, we use a decent amount. Do we got any questions? All right, you got time for homework then? Please let me know if you got any.